And it says the matrix T is such that it maps the point P onto Q. All right, so find the values of C and D. So it says that we're multiplying matrix C, which is C, 0, 0D, and C times the point P, which is 2, 3. That's going to give you Q, and Q is the point 2, negative 3. 2, negative 3. So what is that telling us? That is telling us that 2 times C is equal to 2, and so C equal 1. And what is the next one telling us? It's telling us that 3D is negative 3, and so D must equal to negative 1. All right, so that is C and that is D. So it says determine the image of negative 5, 4. The image of negative 5, 4 on the transformation T will just be, the image of negative 5, 4 will just be, I'm going to keep the same x value negative 5, but then it won't be 4, it will be negative 4. So that will be the image of this under the transformation T. All right. Now it says describe fully the transformation of T. Now I always like to see it on a little graph. I just see it a lot better when I see it on a graph. So I'm going to put a graph right here. And I notice I have the point P, which is 2, 3. 2, 3 can be here. Maybe this is the point P, 2, 3. And then I have 2, negative 3. 2, negative 3 is here. This looks like a reflection in the x-axis. All right, and so the translation T is a reflection in the x-axis. So T is a reflection in the x-axis. That is the transformation T. All right, T is a reflection in the x-axis. Now it says find the matrix that maps Q back onto P. So we need a matrix that's going to map Q back onto P. What is Q? Oh, a matrix that will map Q back onto P. So we need a matrix such that it's going to map Q back onto P. So that means we have negative 2 and 3 here. So, all right. We need a matrix such that we'll multiply it, map it back onto 2, 3. All right. So what's that matrix going to be? This is the matrix. The matrix that's going to do that is we're going to need negative 1 here, 0, 0, 1. All right. Negative 1 times negative 2 give you positive 2. So this is the matrix. So the matrix is negative 1, 0, 0, 1. So that's the matrix that will map Q back onto P. Nice. This is supposed to finish the matrix part and go to the vectors part now. Nice. Exactly. Time for some vectors. So it says now, the diagram or the graph below shows 3 points on a vector P, Q, and R. It says write as a column vector OP. The column vector OP, first thing we need to do is we need to spot the point P. The point P is right here. The point P is 4, negative 1. So OP is going to be 4, negative 1. That's OP. OP, which is nice and easy. Good. Now after we find that, now we want the vector QR. Now vector QR is vector of the last minus the vector of the first. So vector QR is vector of the last minus vector of the first. So vector QR is OR minus OQ. OR minus OQ. that is vector QR. OR minus OQ. That's vector QR. Now OR is equal to, that's what we need to find, OR. OR is equal to, let's see what is OR. OR is 37. OR is 37. And OQ is 02. So it's 37 minus 02. And so 3 minus 0 is 3. And then 7 minus 2 is 5. So vector QR is 3, 5. That easy, that's so easy. Nice. So vector QR is 3, 5. Nice. So now it says find the magnitude of vector QR. So to find the magnitude of vector QR, the magnitude of vector QR, this is how we write it. Magnitude of vector QR is going to be equal to 3 square plus 5 square rooted. That's the magnitude of vector QR. So the magnitude of vector QR is 9 plus 25, which is 34. So the magnitude of vector QR is the square root of 34. All right, that's the magnitude of vector QR. It says now, on the graph provided, draw OS, which is 7, 4, and show that PQRS is a parallelogram. So OS is the point 7, 4. OS is the point 7, 4. 7, 4 is right here. This is the point OS. And then we need to show that PQRS is a parallelogram. So to show that it's a parallelogram, first thing we need to show is we need to show that RS is parallel to QP, and then we need to show that PS is parallel to QR. So that's a lot of work. Let's do that. So can't bother to do the writing around there. Let's work out what's PS first. Now vector PS is going to be equal to OS minus OP. So vector PS is OS minus OP. OS minus OP is going to be, OS is 7, 4. So it's OS minus OP, and OP is 4, negative 1. So 7 minus 4 is 3. That's 3. And then 4 minus negative 1. 4 minus negative 1 is 5. So PS is 5. Now pre this, PS and QR is 3, 5. So we can write that down that PS, vector PS is equal to vector QR, which is good. All right, vector PS is equal to QR. So that's the first one shown. All right, so the magnitudes are the same. And the next one we need to show now is we need to show that RS is equal to QP. So we're going to need to find RS and QP. Now vector RS is going to be equal to OR minus OS. So vector RS is OR minus OS. OS minus OR, and OS is 7, 4, 7, 4 minus OR, and OR is 3, 7. And so RS is 7 minus 3 is 4, and 4 minus 7 is negative 3. So that's vector RS. So vector RS is 4, negative 3. Now next we need is vector QP. What is going to be vector QP? Now vector QP is OP minus OQ. OP minus OQ, OP is 4 negative 1 minus OP minus OQ. OQ is 0, 2. So when you work it out, you're going to see 4 minus 0 is 4, minus 1 minus 3. Minus 1 minus 2 is also negative 3. So you get 4, negative 3. You get 4, negative 3. All right, so as we can clearly see here, RS is also equal to QP. So 2RS is also equal to QP. We've shown that RS is equal to QP. Then finally, their diagonals are equal. All right, which we can clearly see that RP is the same as QS. All right, clearly you can see it. If you don't see it, then you're blind. You can see that RP is equal to QS. Their diagonals are the same. And since RP is equal to QS, and of course all of these are lengths, the vectors are the same, and so their lengths are all the same. And of course, PSRQ is a quadrilateral. And since those vectors are equal, all their lengths are equal. All right. So hence PSRQ is a parallelogram. All right. Once you show these three, then we're good. Because what that means is that all of their lengths are equal. The length of vector PS is equal to the length of QR. The length of QP is equal to the length of RS. And the length of RP is equal to the length of QS. So clearly it's a parallelogram. It's a parallelogram. Nice and easy. All right. So we show that this length, this vector right here, we show that this length, we just put a mark, we show that this length equal this length. We show that this length over here equal this length over here. That show that nice. And then we show that the diagonal lengths are the same. Show that this length, can put 1, 2, 3. This length is equal to this length. So clearly it's a parallelogram. And that concludes this paper. Nice and easy. Was most certainly the shortest paper we've done. And this is 2017 January paper. Easy, soft. Please subscribe to help the channel grow and tune in for more.